Hey there! I hope you had fun in the last lesson analyzing arguments with truth tables. Those arguments, your simple statements, you could definitely determine if they were true or false, and then start analyzing compound statements, joined by and, conditional arrow to the conclusion. But in 3.6, we're going to be looking at some arguments that have those quantifiers, like some, all, none. And we can't set those up with truth tables. It's a little different, some, all, none, not so black and white, true or false. So we're going to use something called an Euler diagram, which will look suspiciously similar to a Venn diagram for these syllogistic arguments. Okay, so a syllogistic argument or syllogism consists of premises followed by a conclusion, which that should sound familiar, but the premises and conclusion can have quantifiers such as some, all, and none. And the validity is going to be determined by using an Euler diagram, which is similar to the Venn diagram, which is what I just said. Oops. So this Euler diagram will have a rectangle for the universal set, and we'll draw circles inside the rectangle for subsets, just like the Venn diagram. But in an Euler diagram, we're going to draw the circles based on what's stated in the premises. So you're going to take premise 1, premise 2, premise 3, and we're going to use those to help us decide how to draw those circles. And what we're going to do when we draw these circles is try to disprove the conclusion on purpose. We're going to do our best to draw it so that it does not support the conclusion. If there's a way to draw it so it doesn't support the conclusion, then your argument's invalid. But if you draw it and it has to support the conclusion, then your argument is valid. If you're going to draw it and beyond a shadow of a doubt it supports the conclusion, then you have a valid argument. But if there's any way to draw it so that that conclusion's in question, then you've got a fallacy. So it's not as cut and dry as doing a truth table and looking at your final column. But I think with enough practice, you guys will get a hang of it. Okay, so speaking of practice, let's do a few. First argument I've got, I'm pulling these right out of the current book in the homework. But I'll go ahead and write them down on here so that you guys know, you have the reference of what they are. First argument, premise 1 is that all planets are satellites. Premise 2 is that Picard is a satellite. And conclusion, Picard is a planet. You might be able to look at some of these and determine right away whether they're valid or invalid. But I still want you to draw your Venn diagram or your Euler diagram so that you have practice doing that. Okay. The quantifying word we have here is the word all. If you see the word all, your Venn diagram is going to be drawn so that whatever you're doing all of will be found inside of another circle. So that's just a general rule of thumb, just to kind of keep that in mind. So in this one, all planets are satellites. We can draw a circle to include anything that's a planet. We can draw a circle to include anything that's a satellite. But when we go to do this, satellites are the bigger item. So in this circle, anything that's a satellite that you could dream of could go in this circle. And premise 1 says that all planets are satellites. So anything that you can think of that's a planet needs to go in this circle. But that circle is found entirely inside the satellite circle because of the word all. All planets go in this circle. They all are found under satellites. Now notice, though, that we still have some space between planets and the rest of the satellite circle, because you could have other things that are satellites that aren't planets. You don't know, so you got to leave that open like that. So the word all, you'll have the nested circles whatever all is, all planets, that circle will be found inside the bigger picture of satellites. Alright, premise 2, Picard is a satellite. Premise 2 does not tell us what kind of satellite, so we can put Picard wherever we please to fit premise 2. But notice that that does not necessarily support the conclusion that Picard is a planet. Because Picard can be drawn right here, satisfying premise 2, but not necessarily supporting the conclusion. So we cannot definitely conclude that Picard is a planet. This is an invalid argument. And there you go. You use the Euler diagram. It has a picture to show that shows premise 1 and premise 2 correctly. It shows that you don't have enough information to necessarily support that conclusion. And that's what you want to do when you're drawing these. You want to draw them and like purposely try to see if you can draw it that so it doesn't support the conclusion. And in this case, yeah, it doesn't. There's a way that it doesn't, so it's invalid. But if it definitely has to support the conclusion, then fine, then it's a valid argument. Alright, let's do another one. Premise 1. All dolphins are mammals. Premise 2. All mammals are vertebrates. Conclusion. All dolphins are vertebrates. Okay, so we have the word all actually appearing quite a bit. Remember, all means you're going to have a circle entirely inside of another circle when you're setting up your premises. Okay, so here's my rectangle for my Euler diagram. The universal set, everything we're talking about in this argument is going to go in this rectangle. Premise 1, all dolphins are mammals. The all goes with dolphins, so that circle is going to be inside the mammal circle. So here's the mammal circle. Everything that's a mammal goes in this circle. And then all dolphins fit in there too. So anything that's a dolphin goes in the dolphin circle, which is also inside the mammal circle. Premise 2 says that all mammals are vertebrates. So this entire mammal circle we just drew has to fit inside the vertebrate circle. Those things having backbones. Because of the word all. And based on that, can we conclude that all dolphins are vertebrates? Why, yes. Yes, we can. This is a valid argument. Valid conclusion. Because all dolphins have to be in the mammals category. All mammals have to be in the vertebrates category, according to the two premises. So from there, dolphins are automatically entirely inside the vertebrates category. So all dolphins are going to be vertebrates. So valid. Okay, another one. Let's see. Premise 1, all Jeffs are Bills. Premise 2, no Bills are Dougs. And conclusion, therefore, no Jeffs are Dougs. If you see the word no, when you go to draw your Euler diagram, you're going to have regions that don't touch each other. So that's something to keep in mind with the word no. And then we already know with the word all, you're going to have basically nested circles. Okay. All Jeffs are Bills. Let's draw that part first. All Jeffs go in this circle. And every single one of those are also Bills, so we got to draw that inside the Bills circle. No Bills are Dougs. When we go to draw the Doug circle, we cannot have it touching the Bills circle because of the word no. And so far, those are drawn based on the premises. Can we conclude that no Jeffs are Dougs? Why, yes. Yes, we can. This is a valid conclusion because Jeffs is safely ensconced inside of Bills, and Bills is having no part whatsoever with Dougs. So Jeffs is not going to ever touch Dougs either, just because of the way it's set up. So this is entirely valid. No Jeffs are Dougs. Okay. Ooh, some. Premise 1. Some skunks are tame. Premise 2. Pepe is a skunk. Conclusion. Pepe is not tame. What the heck just happened? The sum can be one of the trickier ones to do. If you're dealing with sum, and you're drawing a Venn diagram, you're going to have an overlap. So like if you have two circles and you're dealing with sum, there's at least one element that's in both sets. If you're dealing with sum or not, there's an overlap still, but then you're dealing with something that's like outside of that. So just that's generally how the sums are set up. Okay, so let's apply that to our specific problem here, specific argument here. Some skunks are tame. Alright, so since we see the word some, we know we're going to have some overlapping. We're going to have a circle for skunks, so anything that's a skunk goes in that circle. And we're going to have a circle for things that are tame, animals that are tame, whatever, however you want to categorize tame. Some skunks are tame. So right here, some of those skunks that are tame are found in this overlap. There's some skunks that aren't tame, and they're going to be out here. And there's other things that aren't skunks that are tame that are over here. Pepe is a skunk. Okay, so Pepe has to go somewhere in the skunk circle. He could go here, but he could also go here. We don't know. We're not given enough information. So to say that Pepe is not tame isn't a valid conclusion, because we haven't been given enough information to definitely put Pepe in one of those two places in the skunk circle. So that's one of the keys too to deciding on whether an argument is valid or not. It can't have holes. It can't have missing pieces of information. You can't have questions like that that could determine the outcome. So this is an invalid argument. Always look for those holes. See if you can draw your diagram with them. Alright, we'll do two more. Let's see. Premise 1. Some caterpillars are furry. Premise 2. All furry things are mammals. And conclusion, some caterpillars are mammals. This is a prime example of a problem where you have to go based on the premises, not on what you know in reality. I know it's kind of frustrating, but the author of the book purposely set up some of these problems so that premises aren't necessarily reality-based, because they're wanting to make sure you exercise applying correct procedure here to the Euler diagrams. Alright, some caterpillars are furry. So remember, some means you're going to have overlapping circles. So in this one we need a circle for caterpillars. And we need a circle for furry things. And some caterpillars are furry means, you've got some caterpillars right in here that are caterpillars and furry at the same time. Now, all furry things are mammals, according to premise 2. We know that that's not necessarily true in real life. But that is the premise. That's the evidence presented in the court of law. So we have to use it. So all furry things are mammals. If you have the word some, it's an overlap, all, it's nested circle. So the furry thing circle has to be inside the mammal circle. So based on that, can we conclude that some caterpillars are mammals? Even though in real life that's not true, can we conclude that based on our two premises? Well, yes. Yes, we can. Because we have some caterpillars that are furry, those caterpillars are going to fall inside that mammal circle, because the entire furry circle is in the mammal circle. So even though it goes against your real life judgment, we have to say this argument is valid. Unfortunately, the premises aren't necessarily the best, but think of it as an exercise in making sure you know how to set these up. Alright, last one, and then I'll turn you loose to do your own. Premise 1. No squirrels are reptiles. Premise 2. No reptiles are birds. Conclusion. No squirrels are birds. Remember, no means we're not going to have circles touching each other. Okay, so no, yes, we're going to have separate circles. No squirrels are reptiles. So squirrels, reptiles, can't touch. Can't touch this. Alright. Now it says no reptiles are birds. Okay, so we know that reptiles and birds can't touch. But where should we put it? Do we have to put birds down here, not touching squirrels? Not necessarily. Birds could go here and still fit the premises. There's nothing in the premises saying that birds and squirrels don't intersect. I know in real life they don't, but I'm talking about, it sounds like we have a hole here. We cannot, beyond a shadow of a doubt, say that that no squirrels are birds because weren't given that information in the premises. So can we conclude that no squirrels are birds? No. If somebody wants us to draw that conclusion, they're going to have to give us more in the premises. We're going to need more information. Because we could be on an alien planet right now, and without that information, we don't know. Maybe on an alien planet, there are squirrels that are birds with feathers and fly. You know. So, yeah, we need more. So that's invalid. As long as you need more, and as long as you could draw your diagram to disprove that conclusion, it's an invalid argument. Alright, well, I think I've given you a good variety to see, and then now it leaves it up to you to get lots of practice. And this is the last of the material for this unit. This is where we stop in the chapter. I know there's a little more to the chapter, but we're not going further. We're stopping with this. Okay, so next time that you tune in, you should have finished your unit test, and we will be starting the next unit that deals with measurements in geometry. So I look forward to seeing you then. Until then, happy studying!